In this lecture, we will see what are the basic operations which are performed on a binary search tree. There are mainly 4 operations that are performed on a binary search tree. The first operation is search for a node. Second one is inserting a new node into the tree. So we are creating a new tree. Third operation is deleting a node from the tree. And fourth operation is traversal. There are 3 traversals: in order, pre-order and post-order. In order traversal, pre-order traversal and post-order traversal are same as that of the binary tree that we have discussed in a previous lecture. So, we will see these algorithms in detail. First, we will move on to the search operation in a binary search tree. Suppose the following example shows a binary search tree. Our aim is to search for a particular node. Suppose that we are searching for the node 44. We are searching for the node 44. So, search element is X. Algorithm search. The element to be searched is X. So, T is pointing to the root node of the tree. Capital T, it is pointing to the root node of the tree. Then I is used to traverse through the node. So initially I points to the root node of the tree. That is I is equal to T. We are taking a backup of the pointer of the root node. Then if we haven't found the element, we are using a variable done. It is initialized to false, which means that we haven't found the search key yet. Then while I is equal to 0 and done equal to false, do the follow. I not equal to 0 and done equal to false. Do the following steps. Start from the root node. We will always start searching from the root node. If the search key is less than the root node, it means that if the search key is less than the value in the root node, it means that the search key is on the left subtree. Why? Because in a binary search tree, every lower value of a particular node is on its left subtree. So, if the search key is less than the root node, we know that the value is somewhere in the left subtree. Then we move on to the left child. The pointer I will move to the left child of the root node. Otherwise, if the search key is greater than that of the root node, it means that the search key is somewhere in the right side or in the right subtree of the particular node. So we have to move or we have to shift I to point towards the right subtree or right child of the root node. Then if the particular node I contains the search key, that means if I is having the value which we search, we have to return that node's value, and we have to make that variable none. That is like a flag variable. That variable done will be made true. In this case, what happens? We start from root node 52. Then search key is 44. When we compare it with 52, we understand that the search key is lesser. So we move on to the left child. Then we move to the node 36. Then if we compare that 36 to search key 44, 44 is greater. If the value is greater, which it means that the value is somewhere in the right subtree. Then we move on to the right side of that node. Now I am at this node. There we understand that now I is pointing to this node. There we understand that the node is having the value 44. Search key is that node. then we will return its location. That is the algorithm search. In this algorithm, the time complexity, it is big O of log n to the base 2. Similarly, we have seen a similar algorithm in the previous module, that is the binary search algorithm on array. In that binary search algorithm also, we have seen the same complexity and we derived how we reached at that complexity. So our analysis was that after k steps, the number of elements in the array becomes 1. Similarly, after k steps, the number of nodes to be searched becomes 1. So that is the worst case complexity of binary search algorithm. So similarly, we have to derive the same kind of equation. So in this case also, the time complexity of the search operation is similar to the binary search operation for array, that is equal to big O of log n to the base 2. Then next algorithm is creation of a binary search tree, otherwise inserting new node to